Hey guys, thought I'd do a little car video for you. Alright, cracks. Cracks are so much an indicator of what's going on with a structure or anything. So some cracks are just expansion joints, right? They're just expansion joint. Some cracks belong there. If it's not designed into the joint, then the cracks are going to be compressive, or they're going to be open. They're going to be bypassing each other, one over the other, like that. It tells you what's going on. They can also go laterally. It tells you what's going on. So a crack, as you look at it, say on the this one bridge I want to show you guys one day, you got flexural cracks and all that, shear cracks. Those are something we can get into also. But just in general, the cracks, Musketeers, the cracks, an open crack. So if your crack is open at the top, that means it was pushed up like this, some way or another. It's experiencing a moment that's pushing it up, and that gives you your opening. Then it matters as you look at that crack, if one side is higher than the other, then you can start determining which one's experiencing more of an upward action, if you will, or is the other one experiencing a downward action. You can start trying to figure that out. So I want to show you this post-tension bridge, brand new bridge, that has a ton of cracks going across the bridge, laterally across. I think I've got to find the video content for that. It's a brand new bridge. It was never load tested. It's post-tensioned. It's actually Biden was there doing the cutting of it. So the ribbon. So it was never load tested, but before that, the cracks developed. And I want to work on those cracks for some time now. I've been working on them, trying to determine what's going on. And I did not see it with the reinforcement going on and etc. But the cracks are open. They're open cracks. There are a few compressive cracks, explained by probably stone just being so close. When it opened, it knocked a crack out. So the sorry, I gotta keep an eye on the road too. So your cracks are very important. Again, whether they're going in, out, this tells you the direction of the moment, of the force it's applying to that crack, to that area that's creating that crack. So now, what do we have? So just think about that with cracks when you look at them. Some cracks, they tell you cracks are inevitable on concrete. I don't have cracks inevitable on concrete. If you just leave concrete alone, you might get some surface shrinkage cracks. But just leaving it alone, just let's just use a paver, for example. That's a concrete. It's put in the kiln dry and etc. Well, their version is that concrete block inevitably will crack on its own. Well, of course that's ridiculous, my statement. It takes a force to still crack that concrete to come to crack. It's already been kiln dried and everything. It's concrete. So it's not a matter of inevitable or when, or as everybody says, it's not when it's going to crack. Not if, but when. So you have to have a strong base, is what this amounts to. A base. Get that base tight as can be, as you can get that base, and keep that base from moving. And when I say moving, I mean shrinking back. Swelling, of course, would be an issue too, but shrinking back is more of a concern. And that means water, keeping water off of it, drainage, away from that area, keeping that area sort of isolated from a water issue. Now, is that possible? Not on sidewalks. You have cracks in the sidewalk that the water slowly keeps penetrating, going down there and undermining just on the cracks of the sidewalk, because it's not specified that those cracks be sealed. And if they were sealed, that would put the water to the outside, and then you would get like a drip edge effect on the outside of the each side of the pad if it was not, say, butted against asphalt or something that was it wouldn't allow the water to penetrate. So now you have to deal with pitch or drainage. So earth base, of course, you're going to get the earth no matter when. you're going to get to Earth. So there's no such thing as you're going to do it without Earth, right? No matter what, you're going to get to Earth. So you got an Earth base, and then you can add stone there. Your stone is your drainage to help you, if water gets there, to help for expansion and contraction of water, freezing, giving it an area to displace as it freezes. You don't want the water just to be underneath your concrete sitting there as it displaces, freezes, expanding, this displacement. It will jack the pad up. We don't want that. You know that you see ships and everything else, well, that's another displacement thing. But the stone will help, a clean stone will help the water migrate away, and what doesn't migrate away, ideally, it will only be enough in there that will only expand and maybe displace stone next to it. It won't be fully saturated underneath, is what you would not want underneath your concrete pad. You'd want some drainage. With that said, so you have a driveway. Well, you pretty much don't have to worry about the water penetrating your concrete and this field of the driveway, the center part, unless you've got control joints there. In that case, you should seal those up with a backer rod of a type, and that could be foam. And then use a Sikaflex as a brand name, so you can use another product like that. And you're going to just bridge the gap from one wall to the other. It does matter about depth and width per manufacturer. It will tell you your elongation or what it can do. So now you're just worried about the outside edges of your driveway. You want to make sure that water is running off, that water is getting away from your building. And that includes your downspouts from your structure and the surface water that may come to it from another walkway or something like that may enter onto your driveway. You want to make sure that water also doesn't get caught underneath the pad, that it can flow. You just want flow. So basically you want gutters ideally around all of your the way you're thinking about it, gutters around your sidewalk to allow the water to flow away. I don't know what else to say about that real fast. A quick little video for you, a little car format for you as I'm talking, as I do this video for you. Alright, so hope you enjoy it. Don't forget, COVID is real. It is real. It's engineered. And don't forget, exercise. HGH, human growth hormone, is the key. And stop eating crap. Stop eating non-foods. Foods are foods. Non-foods are foods made by Kellogg's Corporation, etc. Goods. Those are goods, and they're not human foods. All right. And I guess I shall end it with that. Thanks for listening, and let's go from here next time.